So now we're going to start talking about how to describe graphs, and we're going to specifically concentrate on quadratic functions because that's what we're working on. And so one way to describe a graph is in terms of the domain and range, okay? So before we can describe it with domain and range, we have to review what are domain, or what is domain and what is range, okay? So domain, what it's dealing with is the x values. And so when you're looking at a graph and you're trying to tell the domain of a graph, you're looking for all the possible x values that the graph will have. Okay, so domain is the set of all possible x values. Okay, so when you've done this in other classes, you just look at the x values and kind of list them. But whenever you're looking at a graph and it's what's called continuous, which the reason why this graph is continuous is because notice there's no breaks in it. And like an easy way to tell if something's continuous is if you kind of trace whatever's on the graph. If you don't have to lift your pencil to be able to draw it, then it would be continuous. And so whenever a graph is continuous, you have to kind of write the domain and the range a little differently, okay? And so we're going to talk about how that works, okay? But domain is you're looking for all the x values that the graph has. And so to find it in a graph, you're essentially kind of looking at how wide the graph is. Because if you think about it, x values deals with the x-axis. And so the x-axis kind of goes left and right. And so you're really with domain, so that says domain right there, you're kind of looking at how far left does the graph go and how far right does it go. And so there's a couple ways to think about that. You can think about how wide it goes whenever you're looking at domain, or you could think about, like I said a second ago, how far left and how far right it goes, okay? So I'll write that over here. So how far left, and then how far right. Okay, so that's domain. Now for range, what you're looking for is, remember, range deals with the y values. So you're actually looking at all the possible y values that the graph has. Okay, so the range is the set of all possible y values. And so when you've done this in other classes, you kind of looked at all the y values that you had and then you just kind of list them. But again, because this is continuous, you have to kind of look at it a little differently. And so when you're looking at the graph, to find the range, think about y values, deals with the y-axis. So if you think about the y-axis goes up and down, so what you're really looking for with range, so that's what that says right there, is you're looking at how tall your graph is. So if I kind of look at my graph and look at how tall it goes, so how far down does it go, how far up does it go, how tall is my graph, then you would be describing the range of it, okay? And so with range, you want to think how far down does it go. You want to look at how far down it goes first, so how far down, and then you're going to look at how far up it goes. Okay, so that's kind of a couple ways to think about these, all right? So what we're going to do is we're going to go down here to these graphs, and we're going to talk about what is the domain and range, and then how do you write it, okay? So let's start with this example down here. Let's see if I can get all this on the same thing, all right? So with this first example, we've got a parabola, which is a quadratic function that we've been talking about. And the thing that you have to remember about quadratic functions, even though it's not written here, is you need to remember that these keep going. So we're going to actually go down there and we're going to write arrows, because if this was a true quadratic function, remember, it's going to keep going, okay? So let's start by describing this graph in terms of the domain, okay? So remember, domain is the x values. So you're looking at how far left and how far right it goes. So how wide is it, okay? So it's just easy to kind of break it up into pieces. So we're going to start with how far left it goes. So if I look at the very left side of this U that's been graphed here, I look and I see the very most left point is right here, right? That's kind of how far it goes to the left. Well, if you think about it, the arrow, there's an arrow right there. And so it's not going to necessarily just stop right there. It's going to keep going. So you can actually think about, okay, it's going to keep going forever and ever and ever and ever in that direction. And so, well, then how wide would it be in that direction? Well, if it keeps going, yes, it is going up. But remember, with domain, you're thinking about how far left is it going to go. And so if you kind of think about it, it's going to keep going ever so slightly to the left forever. And so that actually means it's going to go to an infinity. So when it keeps going, the word infinity is going to come up, because that's what infinity means, is it's just going to keep going. And so what you have to do is think about, okay, what does it mean to keep going this way? Well, look at the x-axis, because that's the domain, and think about what kind of numbers are in that direction. And if you think about the x-axis, the numbers that are in that direction are negative. And so it's going to keep going kind of towards your negative numbers, and it's going to get bigger in a negative sense. And so to show that, you would say that it's going towards negative infinity. It's going to keep going to the negative numbers, okay? So that's how far left it goes. So then let's look at the other side. How far to the right does it go? So we look at the very right-hand side of our graph, and we notice that also has an arrow. And so that means it's going to keep going kind of in that direction forever and ever. So you're thinking about domain. So how far right is it actually going to go? Well, if it keeps going in that direction forever and ever, think about the kind of numbers that are in that direction. And if you kind of look at your x-axis, it's getting to the positive numbers. And so because it keeps going in that direction, it's going to go to positive infinity. Okay, so the domain will go all the way from negative infinity to positive infinity. Now, how do you write that? Well, to show that your x values are going to go all the way from here to here, well, you're looking at the x values, so you're going to put an x in the middle. And then to show that it's kind of going from here, it's kind of in between those two things, you're going to put the x is going to be bigger than these, so it's going to be between negative infinity, all the way from negative infinity to, so you put a less than x, and then it's going to go all the way to infinity. So you actually have to put a less than here as well. So the thing you put in the middle is less than x, less than. And what that actually means is all the x values of that graph are going to go from negative infinity to infinity, okay? Now, sometimes we would put an equals to underneath this, but infinity is not technically a number, so you will never put the equals to with the infinities, okay? So the domain essentially goes from all the negative numbers towards the positive numbers. And so that's one way of writing it. But since it's kind of including all of your numbers, the other way that you could write this is all real numbers. It's including all your real numbers. So sometimes you might see it written like that, okay? And there is a symbol for this. The symbol for all real numbers is they write an R, but then they put like a little line in the middle of it, okay? So that's the domain. So it went from all the way from negative infinity to infinity. That's how wide it was, okay? So then let's do the range. So the range would be how tall the graph is. So remember, you start with how far down it goes and then how far up it goes, okay? So we're looking at kind of the y-axis now. Range is your y values, okay? So if you kind of look at this graph, how tall it was, it kind of started and then it went down. So like it goes all the way down and then it stopped kind of right there. Well, let's look at this graph. With this graph, if we look at how far down it goes, it doesn't pass this point right here. So like that's kind of how far down it goes. So look at that on the y-axis. And then, so it actually doesn't go past -2 on the y-axis. So that's how far down it goes. And then you're going to look at how far up it goes. So if I kind of look at how far up it goes, it actually keeps going up because both of these have arrows. So that's showing that it's going to keep going up. Well, then think about what kind of numbers are in that direction. If we keep going up, well, that would go towards positive numbers. So it's going to go to positive infinity. Okay, so this graph goes from -2, and then it's going to keep going up. So the range would go from -2 to infinity. Now, how do you write that it's between these two things? Kind of like what you did here, but think about which axis you're looking at. With range, it's the y values. So it's going to be the same thing. You still put less than, but now you have to put a y, because range is y values, and then less than. Okay? Now, remember I talked about you will never put an equals to with infinity, but I talked about sometimes you will have to put an equals to. Well, then how do you know when to put the equals to? Notice at -2, right, that point right there, that doesn't keep going like this one did, like with the infinity stuff. It actually has a coordinate right there. The vertex is actually right there. So if it actually has a point, and it's not like an arrow kind of situation, then you want to actually put an equals to, showing that there is an actual point on the graph right there, okay? And so you will want to put the equals to there, all right? So that's one way of writing this, okay? Now, whenever you have a situation like this, and you have an infinity, and then there's a number on the other side, there is another way of writing that, okay? So the other way to write that is you actually cross out the infinity part, and you take what's left and you write that out. So I would write down the -2 less than or equal to y. Now, we don't like our variables on the right hand side, so what I'd have to do from there is flip-flop it. And so the y would come over here, but when I flip-flop it, you want to flip-flop that inequality too. So that inequality will now actually become a greater than or equal to, and then you have your -2. Okay, so what this actually means is the range, all of your y values are going to be any y value that's greater than or equal to -2. And notice, if I look at my graph, if I start like at -2 and I look at my graph, it starts there and then it keeps going up. So that should make sense. So all my y values include -2 and then go above -2. Okay, so that's the range. And then my domain, you could have wrote like this, or you could have wrote it as all real numbers, okay? So then let's practice with another one. All right, so let's say that we had to tell the domain and range for example number 2. Okay, so domain is how wide it is, so how far left and how far right does it go. So start on the left side, and if I look at the very left side, I notice that it has an arrow, so think about it keeps going, so it's going to keep going in that direction, but we're thinking about left and right. So what does that mean? How far left would that go? Well, look at your x-axis, domain, x values. What kind of numbers are in that direction? Well, they're negative. And since it keeps going, it's going to keep going to negative infinity. So it goes, in terms of how far left, it goes all the way to negative infinity. And then we look at the other side. So how far to the right is that graph going to go? So we look at the right-hand side of it. It has an arrow as well, so that means it's going to keep going in that direction. So think about how far to the right does that mean it's going to go? Well, if we look at kind of the x-axis and how far right it's going to go, well, these numbers are positive, so that means it's going to keep going to positive infinity. So this one's going to look the same as what the other one was. So my x values go all the way from negative infinity, less than x, less than infinity. Okay, and then the other way to write that is you could put, when it goes all the way from negative infinity to infinity, you could put the symbol for all real numbers. So that's my domain. My range, remember, is your y values, so it's how far down and how far up it goes. Okay, so, or you could think how tall the graph is. So we start by looking how far down it goes. So I'm going to look, notice it kind of has two spots where going to go down, and notice both of them have an arrow going down. So that means it's going to keep going down. Well, think about the type of numbers that are on the y-axis going down. Those are negative. So because it's going to keep going down, it goes from negative infinity to, well, how far up does it go? So how tall does it go? How far up? So if I look at the very tip top of that U, this is the highest that it goes. So think about what that is in terms of the y-axis. So if you need to draw kind of like a line to kind of see how far up it goes, notice on the y-axis it goes all the way to 16. So that's the top of my graph. So it goes all the way from negative infinity to 16. And now you just, to show that it goes, the y values go from negative infinity to 16, you're going to put less than y less than. Okay, so that's the range. That's one way of writing it. But then remember, I talked about over here, if you have an infinity and a number, you can write it another way by crossing out the infinity part. So if I cross out the part that has the infinity and I write what's left, this is the other way of writing it. And I don't have to flip this one around because it's already got the y on the left. Okay, now I did forget something. Remember, I talked about if there is an actual coordinate at that point, which notice there's a vertex right there, then you actually want to do what's called include that number, because there's an actual y value there. So we want to go back and include our 16. So the range includes all the y values that are less than or equal to 16. Okay, so that's the range. So that is how you describe the domain and range. The last thing we're going to talk about in this video is how to talk about the end behavior. Okay, and end behavior should make sense because it kind of tells you what to look at. So when you're looking at end behavior, you're looking at what happens at the end of your graph. So what is happening at the ends of your graph? What happens at the end of your graph? Okay, and so because there's usually two ends to your graph, there's actually, you're going to have to write two different things. Okay, so that's what we're going to talk about first, and then we'll do a couple examples. So the first thing that you're going to have to write, so I'll just kind of put bullet points, is you're going to have to look at the left side of your graph. So the way to write that is you would say as x, because your left and right is the x-axis, as x approaches, that's what the arrow means, negative infinity. So think about that. Your x values approaching negative infinity. If I look at my graph, the x-axis, the negative numbers go that way. So what you're doing whenever you write this as x approaches negative infinity is you're telling whoever's reading that to look at the left side of your graph. Okay, so as x approaches negative infinity, it's telling the person to look at the left side of your graph. Okay, and then you're going to look at what the function is doing there. So another way of writing functions is like that, and you're going to tell what's happening at the end of that function. And this part is you're going to be telling, does it go up or down? Okay, and there is a way to write that, but that's essentially what you're doing. And then the other thing that you have to do, well, you have to look at the other side of your graph. So then you're going to have to write as x approaches. So the other side would be when it's going to positive infinity. So if you think about the positive numbers on the x-axis goes to the right. So you're essentially telling whoever's looking at this to look at the right side of your graph. And then you're going to tell them what the function is doing on the right side. So you would say, my function, f of x, is approaching. And then you're again going to tell them if it's going to go up or down. Okay, so you're going to have to write something right there. Okay, so let's talk about what does this mean and how do you do it. Okay, so I'm going to actually erase this from where we were working on domain and range, and then we're going to do the end behavior. Okay, so the end behavior for this graph, there's two things you have to write. You have to write as x approaches negative infinity, and then as x approaches positive infinity, and then we're going to write the rest with that. So the first part is as x approaches negative infinity. So you're going to look at the left side of your graph where the negative numbers are on the x-axis, okay? And so if I look at the left side of my graph, it's going up, okay? So what you're going to do is you're going to say my function is, well, if it's going up on the left side, well, think about, now you're going to look at the y-axis. What kind of numbers are going up on the y-axis? Well, that if it keeps going up, then that means it goes to positive infinity, because up is my positive numbers. So you would say my function is going to positive infinity. So when I look to the left, my function is going up. That's essentially what it's telling you. Okay, it's just a fancy way of writing it. So now we look at the other direction. So as my x approaches positive infinity. So when I look in the kind of where the numbers are positive, and I look in that direction, which would be the right side, what's happening? Well, notice on the right side it's going up as well. So then you would say my function is going up. So think about what kind of numbers are up. Those would be positive. And since it keeps going, we put an infinity. So that's the end behavior. As my x go to the negative infinity, so on the left side of my graph, my function is going up. As x approaches positive infinity, so when I look on the right side, my function is going up as well. So that would be the end behavior. All right, so then this one. What if we had to do the end behavior for this one? You started out the same way. You're going to look and say, okay, as my x's go to negative infinity, so on the left side of my graph, and then I'm going to look at where the x's go to positive infinity, so the right side of my graph. So when I look at the left side of my graph, notice the function is actually has an arrow going down. So the function f of x is going down. So what kind of numbers are down? Well, if it keeps going, the numbers that are going down are negative. So that actually means that it's going to negative infinity. So we put a negative infinity. So now the right side of my graph. Well, the right side of my graph, it's actually going down as well. So then you would say my function, and think about what kind of numbers are that way. And if it keeps going, those numbers are negative. And then if it keeps going, then it would be going to negative infinity. So on the left side of my graph, it's going down. On the right side of my graph, it's going down forever as well. Okay, so that's a couple ways that you can describe the graph.